Good morning, everybody, and welcome again to the CEIA Maths tutorials. Today we have integration, and it's going to be delivered by Mark Murphy, who you've met already.
Thanks, Eamon. Good morning, everyone. So this morning, I'm going to talk to you about integration. But first of all, I'll introduce myself. I don't know if any of you are here for the Geometry Line, but Mark Murphy is my name. I run a company called MM Consult. We're consulting engineers, or structural engineers specializing in bridges. So we'll talk about integration. So first, it's quite a small subject, really. There's only 4 things you need to know, and I'll write them out here. It's quite a short. So the first thing is to recognize integration as reverse, it's an E, reverse differentiation. Name of space. Okay, the second one is to use integration to calculate the average value, right? So use integration to get the average value of a function. And again, that's quite short. There's not a lot to it. Number 3 is integrate sums, differences, and constant multiples I'm getting this straight from the Department of Education document, right? So it's a bit boring to start, but we just get through it. And of a few different functions, right? Of a few functions, right? And we'll do that later as well. There's only 4 of them. I'll write them out here. Look, so it's the, let's say A is x to the power of A, B is A to the power of X, C is sine A x, and D is cosine AX. So there's only 4. And then the final thing, and probably the most interesting, is the determining areas, right? Under a graph. So that's it. There's only 4 things that you need to know going into the exam. But at the start here, I just want to introduce integration and tell you where it came from and how it developed. It's quite short, but it's the most important thing. If you understand this, actually the other 4 are very easy, okay? So, I'll go to the next page. Okay, so first thing I'm going to do, I call it chapter 0, because it's not one of the 4, right? It's integration as summation. So integration as summation. Okay, now integration is introduced as a means. So I write it down here. This is kind of this is what integration is. I'll do a different color, black. It's a means, and this is important actually, as a means of finding areas using summation and limits. I hate words in maths, right? I'm not going to use a whole lot. I'll get out of the way to start. So really what's that saying, right? Let's do an example. So it's saying, if you want to find the area of something, use the areas of things that you know, and you add them together, and you use limits or boundary conditions. So it is related to differentiation, right? And like 2 weeks ago, I said about Geometry Line, if you understand it, you don't need to do examples, you don't need to do past papers, you can just go in there and do it. With integration, I would recommend that you do need practice. So you need to do a few questions, and you can see, I suppose you build up a kind of a memory bank of how to solve different questions. So the core idea of integration is we can find the area of a shape by dividing it into small shapes whose areas are easier to calculate. We then add up the areas of the small areas, right? Of the smaller shapes. So for example, if we had, say, something like this, just do that better. And like this, just draw something random. Now, if you were asked to calculate the area of that, it would be quite difficult, wouldn't it? You know, but let's divide it up into areas that we know. So that's, let's say that's area A, that's area B, let's say that's C, and that's D. So in this case, we had an odd shape. So we can say that the total area of that there, right, is equal to the area of A, right? We just say subscript A plus the area of B plus the area of C plus the area of D. That's pretty straightforward, and everyone understands that, right? So we had an odd looking shape. We couldn't calculate the area, but by dividing it up into smaller areas, smaller shapes that we know the area of, for example, I mean, we all know the area of a rectangle, we know the area of a triangle, okay? That's how you would solve that problem. Now, let's hope this works. I'm going to bring in another one. Let's go to photos, albums, integrator. If I bring in something like this, okay? This one is over here. Okay. Okay, say we didn't know the area of the circle, right? Way back when they didn't have pi r squared, okay? How would we calculate the area of this circle? Well, one way you could do it is to divide it up into smaller areas, like of squares. For example, in this case, it's squares whose area we know. For example, like, let's say that's 1 by 1 square, right? So we know that little area that we call it A, that's equal to 1, we call it unit or meter squared. Let's say they're meters, okay? And we add up all those A's. Now, we don't know the area of the circle still, right? So let's say, for example, let's count up all the gray squares there, okay? Let's say, so we call it, what we're looking for here is A of the circle. I'll call it A naught, okay? Now, if we added up all the areas of the gray squares, well, that would be less than the area we're looking for, wouldn't it? Now, if we add all them up there, look, what is it? That's 8 by 6 plus 6 here and the 6 here. Just undo that. So that's, if I add up all the gray squares, I get 60, right? So we know that the area of the circle, well, it's definitely bigger than 60, okay? So basically what I'm looking at there is all the squares that are contained within the circle. So all the squares there, the gray ones, are all contained within that circle. Now, if I add all the squares that are outside the circle as well to it, so all the white ones, right, I get 60 plus, we add up all those white ones on the outside, there's 28 there, right? So that's 60 plus 28, that's 88, okay? So I know that the area of the circle, I know that it's bigger than 60 and it's less than 88. Now that's still not very accurate, right? So how can we improve on this? And basically what I'm getting into your heads here is the kind of core of integration, and we'll do the more general one under a curve later. So what we could do, I'll just get a blue pen. What if we made the squares smaller? Now this could be disastrous, but I'm going to try. So if we made a line across here, a line across here, and a line across here, like that, okay? You can see what I'm trying to achieve anyway. And we'll do the same going vertically. Now we have smaller squares. So for example, we have this square now, okay? Now the area that is 0.5 by 0.5, so let's say the area of the blue one there, right? So that's A is equal to 0.25 meters squared, isn't it? That's right, 0.25 plus 0.25 is 0.5. So now I'm not going to do it here, right? But if we added up all the squares now that are contained within the circle, in other words, the squares that don't go outside the circle, we might, for example, I haven't done this outright, but it might be, let's say, like, what is the area of the square? What's that? About 1, 2, 3, 4, 5. I don't know. It doesn't matter actually, right? But say that this comes up to like 72, right? Within side, and the area outside, then we do the same outside and we get like 74. So now we know that this is only an example, by the way, I haven't worked it out exactly. But now, by making the grid smaller, we're getting closer to the real answer. Let's say, for example, the answer was 73. I don't know, right? But for example, but now we're much closer. Like in the first case, we were quite far like this. That's a range of 28. So like, that's not very accurate. But by making the grid smaller and more refined, and the distances between the squares, obviously the length of the square is smaller, we're getting more accurate. And if you kept dividing up the squares smaller and smaller and smaller, you'd finally end up with, like, for example, 73, it's less than 73, all the squares inside were 73, A naught, and the squares outside were 73. And therefore you could say that the area is 73. Okay. Now, if anyone has any questions about what I'm doing, if I'm going too fast, please use the chat function, right? But I just want to get, this is really the core of integration, and like it's a means of finding the areas using summations and limits. So the summation here was adding up all the little gray squares and adding all the white squares and adding to the gray squares, right? That's the summation. And the limits then really is how big those squares were, right? So by making the squares smaller, we're getting a more and more accurate answer. So that's really the core of integration. Now, let's go on to the one you're probably more used to. It's the area under a graph. Now, I'm going to introduce like delta x's and delta y's and dx's and dy's. Don't get bogged down in all them, right? Just keep remembering back to the circle. What we did, we just got something that we knew the area of, and we added it up, and we got a limit. We got, what's they call it? A lower limit was the gray squares, and an upper limit was the gray squares plus the white squares. So what we did, we had a lower limit and an upper limit, and we just brought them closer together. And the closer they are together, the more accurate your answer. Okay, that's pretty much what we did. Okay, so let's say the area under a graph general. Okay, so say for example we have the x and y axis. So that's your y axis, that's your x axis, and let's say we just have some function, and we can give it a different color, gray. So we have some function like this. Okay, we can call that f of x or whatever, right? So that's just some curve. Okay. Now, we want to find, so I'll write it down here, maybe it's easier for you. We want the area defined by the curve. So in first place, the curve, the x-axis, y-axis, and the ordinate. I hate all these words, but anyway, I suppose we have to use the ordinate A. So what's the ordinate A? I'm just going to define it there and use the gray again. So this is just A here, right? A is just the line going vertically up there. That could be 6, it could be 7, it could be 552, it doesn't matter, okay? So we have the x-axis, the y-axis. So what we want to find, I'll shade it here, I'll hatch it, and then I'll take it off again just for clarity, right? So that's the area we're looking for, right? The area underneath here. Okay, that's all we're asking for. How would you do that? Like, there's no method to that, you know, there's no really areas. So we're going to use the same principle that we did with the circle. Okay, so what I plan on doing here is introducing a point P first of all. So let's call that point P. Okay, and we give point P let's say that's X and Y, right? So let's go down here. So that's X, and this is Y. So P has the coordinates X and Y. Let's box that off. So P has the coordinates X and Y. Now, what are we going to do here? How can we solve this, right? What if you divide it up into little strips, loads of strips, right? So let's put in the point Q, here. But remember before we want the small strip, right? So what's the coordinate of that? Okay, so I'll just do a dotted line here. So we call that, what can we call it? So for example, if X was like 5, right, and we want to make a really small strip, we'd say the next, we'll just go over, 1,000th of a unit, so it'll be 5.001, right? But in this case, we just call this, right, X, sorry, that's bad, do that again, X plus delta X. Now, this is what I'm introducing, this whole concept of delta X. Delta X in this case is just a really small number. So for example, if X, as I say, X was 5, and we went over 1,000 of a unit, then delta x would be 0.0001. So for example, x is 5 and the second coordinate is 5.001. So we've gone over a really small, now obviously I've blown it up here so you can see it, right? So let's do the same thing with the y, right? Let's say that the y coordinate of q is y plus delta y. Now, I'm just going to change the color of the pen to blue, okay? Now what have we got? We have a strip here of delta A. So the area underneath that graph there, right, is delta A. So I just draw it here. So that's here, between here. I don't want to do there. I just took that out. So just from here down to here, I'm going to take this off again. That's delta A, okay? So what's delta A? Delta A is just, right, what we're trying to calculate here is A, right? The whole area is A, right? So the area under the graph bounded by A, by the x-axis and y-axis is A. That's what we're trying to find, capital A. I should make that, might be a bit confusing. Make that A, that's small a there, okay? Right. So now we have the coordinate of Q. So Q is defined as x plus delta x and y plus delta y. Okay. Now we're looking for delta A, okay? Now we still haven't really got any areas that we know, but what if we just put, I know it's a bit small here, but I hope you can see it. I'll change it to red, actually, easier. Okay, what if we made this, just put a line across there, okay? What if we just continue this line up here and this line across here, okay? No, it's very small, I know, okay? But I'll do it out nicely for you. So we're looking for delta A. So let's write down delta A. So I'll write down delta A here, right? Going back to the circle thing, well, we know that we know delta A is the area under the curve, right? Between x and delta x, okay? Now, we need to find something that's smaller than delta A, but look, if we look here, right? What's this x plus delta x? So that distance there, right? That distance is delta x. And this height is y, isn't it? So again, I'm going to shade this in and then I think this works nicely. I'll try this one. So this is the area we're looking at now, first of all, right? This one. Okay. That's the area, okay? So that is delta x multiplied by y. That's the rectangle, okay? I'm going to take that off. So we can say that delta A, well, it's smaller than that. So we can write down y. Oh, turn that off, sorry. So y delta x. So we can say that the area under the curve of that strip is bigger than y times delta x, okay? But then similarly, we can look at another rectangle. So I'll do it again in this, I'll change color pink, right? So if we look at another rectangle, so it's this rectangle, okay? What's the area of that? Yeah, just take that off again for clarity. But that's the rectangle. So we know that that's bigger than the delta A, so we can write it like this. Well, the width of it is the same, right? So it's delta x, but the height now is y plus delta y. So that height there, right, is y plus delta y, but the width is still the same. So we can say that y plus delta y times delta x. So that's like what we have here now is the delta A is what we're looking for. We know that one rectangle is smaller than it, and we know that the other rectangle is bigger than it. That's similar to what we had with the circle and dividing up into squares. Now, what we're looking for is A, right? So that's the sum of all those strips. If you can imagine, if you add up all those individual strips, we'd get A. So we can say that the sum of all strips, that's A, isn't it? So A is equal to, I presume you've all done summation, right? So that's the summation between x equals A and x equals 0 of delta A. Now, again, that's a big, massive wordy kind of a thing, right? But all that really is saying is that if you calculate the strip of the area of one strip, right, and you add up all those strips, then we have the area under the curve, which that's what we're looking for, okay? Now, I'm just going to apply that same summation to this, right? So I'm just going to rewrite that, okay? So this then becomes the sum, and instead of writing x equals A, I'll just write down A, right? 0 y delta x is less than A. We just replaced, the sum of delta this by A because that's what we just defined it. And it's less than the sum, well, I did that too much, of it being A and 0 of y plus delta y delta x. Now all we've gone from there, right, is just calculating the area of one strip to calculating the area. So now we're getting close to what we want, right? We have this summation here is less than A, and this summation here is greater than A. That's all that's saying, right? Now let's just write this out. I don't really have a space, but I'd like to keep them on page. So I move over here, okay? Now, if we just rewrite that this way, right? Actually, do you know what? I'll give you a second. I'm going to move on to another page because it's too important. Okay. So I'm just going to rewrite that for you. So we had the sum of A 0 y delta x less than A, and then we had the sum of A. I'm just rewriting the last line I did, right? Y plus delta y times delta x. So the area is less than one rectangle, or sorry, one summation and greater than the other summation. So just rewrite that again. A 0 y delta x is less than A. I'm just going to write out this bit now. So sum of A 0, I'm just going to bring the delta x in, right? So y delta x plus delta y delta x. Okay. Now this is the key to one of the keys to integration, right? Is making the delta x as small as possible. So how do we write that in mathematical terms? We just say we let delta x go to 0. Remember limits? So in other words, we just want a thinner strip. So I write down thinner strip. Okay. Now how we do that is we say that A. Now if you look at that, right? If we go back up to the line above, so the middle line there, okay? If we let delta x become small, right? And delta y very small, right? But we leave that less, because if you make delta x smaller, then delta y will get smaller as well, right? Now, this is kind of the concept of if you multiply a small number by a really small number, so two really small numbers, they pretty much go to 0, right? So this is the key to it here, right? We say that goes to 0. But it's true, right? Because if you would like 0.000001 multiplied by 0.000001, right? Then that's going to be really, really, really small number, right? So if your delta x is incredibly small, then obviously delta y by delta x just becomes insignificant, right? So that's the concept of limits. So what we then say is that A is equal to the limit. This is important, actually, this limit of delta x going to 0. Sorry, that looks like infinity sign. I'll change that. Delta x going to 0. A x equals 0. And write out properly x equals A of y delta x. So go back up to that line there where I just got rid of this, right, point to 0. If you get rid of that, then you're left with the same on both sides. So you see what we've done? It's the same with the circle. We've made, by reducing the delta y and delta x's, we've actually made both sides of it converge so that we can say that A equals the sum between A and 0 of y delta x. But what's important is when delta x goes to 0, that's the important bit, right? In other words, we made the strip story thing, that's all it is. Now, this is quite a lot to write down, isn't it? That part, right? So instead of writing that out the whole time, what we actually use is the notation you're probably familiar with, those who've done integration. Instead of doing that, we just say that we use this kind of squiggly s y dx. And instead of delta x, we just call it dx. That's it. So they're the same, right? But you don't really need to know that. But that's integration, right? So the integration, so let's go back then and rewrite this, right? So if we want to find, let's give you a second to write that out. Okay, so going back to this, right? So we have this f of x, right, or y, right? It doesn't matter. So we can write out, so equals y. So we're saying that the area underneath this, right? The area underneath this is simply integrate between A and 0. So that's 0 there, I should write that in. That's A. I should have wrote that down too. A, 0 and A, right? So the area underneath that curve, which is this one under here, is given by y dx, right? R equals, you could write it another way, A is equal to the integral between A and 0 of f of x dx, because y equals f of x. So in other words, y is a function of x. That's all it says. Okay. Just one other thing on that, while we're here, let's draw this one. So what we did there, we did it between A and the y-axis, right? So A, it was like one was 0 and one was A, right? They were the two verticals. In another case, you could have something like this. So you have x and you have y, and so the same curve again like that. But in this case, we have, say we want to define this area. So in other words, that area is defined as the area under the curve between the x-axis and A and B. Okay, so in other words, what we can say here is that the area is equal to so that's y, we just call that y, right? Or maybe f of x, or yeah, f of x, I prefer f of x. So that curve is f of x, it could be 6x squared plus 7x or whatever, it doesn't matter, right? So we say that that's equal to f of x, that's 0 there, f of x dx, okay? So it's that, by this 0 here, right? I did it in a different color. What I just wrote there in red, well, that's this area, isn't it? Because it's between B and 0, okay? So A is equal to, but that's not what we're looking for. So that's equal to f, oh, sorry, that's 0. Apologies. F of x dx. So I'll do this in blue. So this area, well, that's this area here. Okay, that's that area. So what we're looking for is the area in a different color, pink. So this is the area we're looking for. So that's basically, oh, sorry, that's not minus there. My apologies. I don't know. Just rub that out. That's not equals. That should be minus. Okay, so basically we're saying that the area that we're looking for, the pink area there, is the area between B and 0 minus the area between A and 0. Okay, that's straightforward. But instead of writing out like that the whole time, we can write it like this. The integral between B and A of f of x dx. So we box that. That's what you need to know there. And this is what you need to know here. So the only difference between those two really is that one is between B and A and the other is between A and 0. That's all, okay? Nothing too. Now, again, with all these things, it looks a bit messy and a bit, complicated. Once we start doing proper examples on this, it'll become a lot clearer. Okay, so we've done integration and summation. That's really the introduction, okay? Now, the next one came up the last 2 years. So maybe it might come up this year, but we don't know, or next year. So the first thing I want to do here is, and if there's any questions on what I just did there, use the chat function, talk to Eamon, and I can go back and explain something, because that was really an introduction. And if you understand that concept, then integration as a summation will not be an issue. And it is important because if you learn up, you went, I think it was about 6 years ago, they threw a wobbler, kind of strange question where you didn't have, you couldn't get the curve. It was actually a series of different shapes. And everyone, I think a lot of students were looking for the curve, and there was no curve, so they couldn't use their formula that they'd learned off by heart, right? But all it was really was, dividing it up into areas that you knew and just summing it. So maybe I might get a chance to do that question later as well. But in other words, understanding the concept of integration, of breaking up, let's say, a strange area that you don't know, I don't have a formula to calculate the area, by breaking it up into smaller areas that you do know, and then adding them together. So that's the summation, and then the limits is between A and B or whatever. That's all that is, okay? So let's do the first one, right? So the first thing is integration as reverse differentiation. So integration. Okay, this is the first one we're going to do. So what this is saying, and I'm going to use the terminology they use in the exam paper as well. If we start with a given function, so if we start with f prime of x, right? And those of you who've done differentiation last week know what that is. If you start with f prime of x and ask what function or function f of x, so if you have f prime of x and you say, what function f of x, gives you by doing the differentiation and f of x, you go, what function of x, so I read it actually. What function of fx would have, I've got the capitals here, it doesn't matter, would have f prime of x as their derivative. Again, I don't like all the wording and all this, but we'll do an example to be clear. Okay, so what it's saying there is like, what function f of x would have f prime of x as the derivative? Because that's, dy dx can be written as f prime of x. So that's what I just write that now. That's equal to dy dx. Okay, so there you're saying. So that's where it's the reverse process. Now, the best way to do this, I think, is just give you an example, right? So let's say we start with f of x is equal to 3x squared plus 7x plus 2, right? Now, we all know to differentiate that. So if you differentiate that, you get f prime of x equals 6x plus 7. I presume that's clear to everyone. I'll just change the pen, right? So what we've done here is we've gone from this one to this one, right? So the arrow is important here. So what we've done there is we took a function f of x, we differentiated it. So we write down differentiate. Okay, so we took 3x squared plus 7x plus 2, differentiated it, and we got 6x plus 7. Now, what I asked above was, what function fx would have f prime of x as derivative? So we're working the other way. So if we start with 3x squared plus 7x plus 2, right? We're saying I'll work it the other way. So what function, I'll draw it, it's easier to draw it. So what if we wanted to go the other way? We wanted to find out what function starts off to give you 6x plus 7. That's what it's saying, right? So this is the reverse process. So you're starting with this and you want to get that. And we call this the antiderivative. Process is called anti-differentiation. Okay. Now that anti-differentiation is also defined as integration. So you put it in brackets, integration. So the only thing you need to take from this actually is that integration is the reverse process of differentiation. So with differentiation, you start off with 3x squared plus 7x plus 2, and you get 6x plus 7. And integration or anti-differentiation is just the opposite. You start with 6x plus 7, and you get 3x squared plus 7x plus 2. Now, one thing to know though is, what if I change the 2, right? Say instead of plus 2, we have plus 11, right? Or plus 17,000. Doesn't matter what it is, right? And they differentiate it. I'll still get 6x plus 7. So that's the problem. It doesn't matter what the constant is after that function, right? Or the constant within that function. When you differentiate, you get 6x plus 7. It's the same answer for all of them, right? So that's an anomaly we need to figure out, right? So the constant term disappears. In other words, the 2, the 11, and the 17,000, right? They disappear when you differentiate. But to get the correct answer when we go back the other way, we need to introduce something called a constant, right? So I read it out another way. So if you want to integrate 6x plus 7, so I just remember that squiggly line, 6x plus 7. So we do it like this. So we had y equals our fx. Well, I keep it fx anyway. So f of x, right? So f of x is equal to 3x squared plus 7x plus 2, and then f prime of x, or dy dx, right, is equal to 6x plus 7. Now I'm going to do it the opposite way. So that's the first way. The opposite way then is 6x x plus 7, right, dx. That's the next there, sorry. Okay, 6x plus 7 dx. So when you integrate that, we need to get 3x squared plus 7x plus 2, don't we? So we know that. I'll show you later the rules, right? But that equals to 3x squared plus 7x. The problem is now, how can we get to 2? You know, we say it's 2, but we also know that it could be 11, it could be 17,000, it could be any number. So what we do is we introduce this, and I'll change the color. It's really important, this is where we introduce C. C is just a constant term, right? For any constant. So in other words, when you start with 6x plus 7, you can end up with any C, and that's the correct answer. In other words, if you were started on the right hand side, 3x squared plus 7x plus C, and you differentiate it, well, you get 6x plus 7, okay? Now, what's important here, this is the basic, so I'm going to write down here the basic rule of integration for polynomials, right? So if we start with f prime of x, right, equals x to the power of n, right? And this is important, where n is not equal to minus 1, then f of x, so in other words, f prime of x is just a differentiation. It could be anything. Again, when we do examples, it becomes clear. So then f of x is equal to x to the power of n plus 1 all over n plus 1. And you think that's it. Don't forget the c. Okay, and that's the most important thing to know, okay? For polynomials, okay? So it's called the basic rule of integration. So we write out another way, or you can say that the integral of x to the power of n dx is equal to x n plus 1 all over n plus 1 times plus 1. But again, plus c. Put that in the box, right? So that's integration as the reverse process of differentiation, right? So, and I'm going to introduce a new concept here. Again, it's really important, and it confused me when I was doing my research a few years ago. It's the difference between I'll give you a moment there just to write that up first. It's the difference between the definite and the indefinite integral. And what does that mean, right? Okay, move on. So it's the definite and indefinite integrals. Okay, so indefinite, first of all, let's show you indefinite. So that's like a function f of x dx. That's the indefinite integral, okay? And the answer to that is, well, I call this f prime, right? Just for now, doesn't matter. For the integral of that is f of x plus c. We did that already, right? That's just the reverse process. So if you started with f of x and you differentiate it, you get f prime of x. And if you do it the opposite way, if you start with f prime of x, so in that last case was 6x plus 7, and you integrate it, you get the 3x squared plus 7x, right? Plus c, because that's indefinite, okay? So the solution to an indefinite integral, well, it's another function. So you start with a function and the answer is solution. So I say solution is another function. Okay, so like a while ago, that was the answer was 6x plus 7, wasn't it? 6x. Oh no, the integral was whatever it was, right? I'll go back to it. So the answer was, when we integrated it, we got 3x squared plus 7x plus c. Well, that's just another function, okay? That's all that's saying. Now, for the definite integral, so write down definite. And this is the difference between indefinite, there was no limits. In the definite, in other words, it's more defined, we have limits. So we say between b and a of f prime of x dx, well, that's equal to, I'm going to write this now for you. So it's some function of b, so it's a function of b minus a function of a. And that solution is a number, right? Solution is a number. Again, we'll be doing examples later and it'll be clear, okay? Actually, maybe I might do an example now. So that's important, right? That's the difference between a definite and so that, in other words, what I'm saying is the definite, you get a number. Okay, I'll give you an. We'll try and do this one. Let's see now. Definite or indefinite. Okay. So we already did, I tried the one actually we did a while ago, right? So let's say we want to get the integral of 6x plus 7, right? That's what we had a while ago, 6x plus 7 dx. So the indefinite we did already, but in this case, what if we add some limits? So let's add the limit of, let's make it easier on ourselves, 2 and 1, right? So in other words, we want to find the area of that curve 6x plus 7. We want to find the area under it between 1 and between 2, okay? Let's see what happens. So you remember the basic rules, so 6x, so x to the power of 1 goes to x squared all over 2, so that becomes 3x squared. So just looking at 6x first of all, that becomes 3x squared plus 7x. The notation you use then, right, the 2 and the 1, this is how I do it. I think maybe you do that as well. So now we have that. We've integrated 6x plus 7. We've got 3x squared plus 7x. There's no c here because we have limits, okay? So 3x squared plus 7x. So that then equals, we fill in for 2 and we fill in for 1. So that becomes 3 times 2 squared plus, plus 7 times 2. That's the first, right? And then that's the first area. Remember we were talking about the b, between b and 0. And then you subtract it from the a and 0. So that's minus, so I put this in brackets, 3 times 1 to be squared plus 7 times 1. Okay, so we filled in for 2 and we filled in for 1. So working all that out, you get 4 is 12, 12 plus 14, minus 3 times 1 is 3, plus 7 times 1 is 7. So that becomes 26 minus 10 equals 16. So you can see the answer is a number when you're given limits, whereas the other time the answer was 3x squared plus 7x plus c, right? So that's the difference between definite and indefinite integrals. Okay, so that's the first thing done, right? We've done differentiation as the reverse process, sorry, integration as the reverse process of differentiation. The second one is integration using tables, right? And all these are in your log tables, so it's going to be quite easy. So we'll just write it out. Okay, there's only 4 you need to know, as I spoke at the start. First one, A, is the integral of x to the power of n dx. And we already did that, so the answer to that is x n plus 1, x to the power of n plus 1 all over n plus 1. And because it's indefinite, plus c. The second one, again, these are just definitions. You don't need to know where they come from. A to the power of dx, right? Well, that's given in your books, in your log tables as well. That's equal to a to the power of x all over the natural log of a, or ln a, plus c. Next one is the sine of ax dx. Now that a could be 4, 5, a number. It's a number, okay, or a constant. So that's equal to minus 1 over a cosine ax plus some constant c. C could be anything. It could be d. You could write it could be 7 million, right? It's just a constant. And then d is the cosine ax dx. So that's equal to 1 over a sine ax. And you can see here, the sine goes to cosine, it's divided by, just watch out, it's minus 1 over a, whereas when you integrate cosine of ax, you get 1 over a sine of ax, right? So just watch out for that. That's all you need to know, right? And it's in your log table, so you don't really need to know. So like usually the first part of the questions is like one of those 4, they give you a thing and they say integrated, and you know, it's easy marks. Okay, so a few extras, right? So we'll do the rules of it. This is important, the rules of integration. I don't know if this is in your books, but it's just something to make things a bit easier in the exam, right? So there's only two. One, if you have integral of c times, I'm going to introduce u of x and v of x here, right? That's still, it's just some function of x, right? Maybe you've used u and v before. So for example, u of x could be 3x squared plus 7, right? Or it doesn't matter. Vx could be sine x, right? Doesn't matter. So c times u of x dx, right? So that's equal to, you bring the c out, so you can bring the constant out, right? So the constant comes outside. So you're just saying that's equal to the integral of c times the integral of u of x dx, right? So I'll give you an example. For example, the integral of 5 times the cosine of 4x dx can be written as 5 times the integral of cosine 4x dx. Okay, so all I did there, right, is I took the 5 out. The second one, the second rule is if you have an integral like the u of x plus or minus, doesn't matter, v of x dx, right? So if you have an integral like that, you can write that as the integral of u of x dx plus the integral, plus or minus the integral of v of x dx, okay? So for example, what do you say, i.e., if you had like, you know, the integral of 4x squared plus the cosine of x dx, you can write that as equals, right, the integral of 4x squared dx plus the integral of cosine of x dx. That's next there. Okay, that's just to, you know, sign the exam. If you get something that looks really complicated, just break it up, right, using those two rules. So now is a good time, I think, just to do some examples, because this is what will happen in an exam, right? So let's say this is using, I had up here what I have, A, B, C, D, right? So I'm going to use the same notation. So the first one would be an A. So we say A. This is an example of A. So if you had the integral of x squared plus 3 dx. So you keep it simple, just makes, so first of all, we can break it out using the second rule, right? So that's equal to the integral of x squared dx. When you get better with these, you won't bother separating out because you see the answer straight away, right? Plus the integral of 3 dx. Okay, so x squared ux is xn, so n in this case is 2, so it's xn plus 1, that becomes 3, and you divide it by n plus 1, so the integral of x squared is x cubed over 3. Okay, that's clear, isn't it? And similarly, with 3, right, 3 is actually 3 times x to the power of 0, isn't it? Because anything to the x to the power of 0 is 1, so in this case, the x is 0, so 3, x is 0, 0 plus 1 is 1, divided by 1 is x. So the integral of 3 is 3x. And don't forget your c, because it's an indefinite integral, right? So that's the first one. That's an example of A. Now, inside an example, will just be some variation of that. So B, let's see, is the answer 2 to the power of x dx. You get that straight from your log tables. The answer to that is 2 to the power of x all over log 2. But again, don't forget your plus c. And then the second one is a C and D, right? It's an example of C and D. So for example, if you had, right, I'll put in limits this time. If you had pi over 3, so this is, the first two were indefinite. It's like this third one here is a definite integral, right? Because we're given limits. Cosine of x plus 3 times the sine of x dx, right? So we'll go back to our log tables. We know in this case, cosine 1x, right? So cosine becomes sine of x. So that becomes sine of x. And 3 times the sine of x becomes minus 3 times the cosine of x. Okay, and then, sorry, that should be a square. And the limits are pi over 3 and 0. So we fit in for pi over 3. So again, it's the bigger area minus the smaller area, right? So pi over 3 to 0 and 0 to 0, which is obviously 0. So that's equal to the sine pi over 3 minus 3 times the cosine of pi over 3, right? And that's the bigger area, minus, and then you fill in for 0. Sine is 0. Sorry, sine is 0, yeah. Minus 3 times the cosine 0. Okay, so that becomes, going through log tables again, sine of pi over 3 is the square root of 3 over 2 minus 3 times a half minus the sine of 0 is 0 and the cosine of 0 is 1. That's minus 3. And then work all that out, you get, I won't work it bore you know, but it becomes, I'll write it out. 3 root of 3 minus 3 plus 6, isn't it? Yeah, plus 6 all over 2. That's equal to 3 plus root of 3 all over 2. Okay. So we've gone through everything there now. Use integration using tables. There's only 4 you need to know: x to the n, a to the x, sine of ax, and cosine ax. And then in the exam, it's usually part 1. They might add a few of those together, throw in some limits, and look, we've covered everything there. So that's all that done, right? Okay, so we've pretty much gone through a lot of I would say boring stuff, but it's important stuff. So like there's only 2 parts left to do, and they're quite quick, right? So areas by integration is the third one. The last one is only just one line. Okay, so integration was initially introduced to find the area under a curve. Okay, so there's 5 different ways they can throw this up in the exam. So let's there a second. Yeah, so I've put out the 5 different ways that the areas come up under a curve. There are some little tricks and some things you need to be aware of, right? Because things can go wrong unless you do these. So the first one is very basic, and in fact we've done it already. Okay, so you have the x and the y axis again. So x, y, and you have a curve, and you want to find the area between A and B. So in other words, this is the area you're looking to get. Okay, and this is the curve y is equal to f of x. Okay, so the area under that curve is given by the limits between b and a of f of x dx, right? And this is for, let's say this is for a curve above the x axis. Okay, that's the one we've done already, right? It's pretty straightforward. Okay, so if you're given a curve, f of x could be 7x squared plus 25x plus 3, right? Whatever. And you want to find it between b and a between 5 and 2. That's the formula you use, okay? Now the second one is very similar. So you have your y-axis, your x-axis, right? X-axis. And in this case, say the curve is underneath, right? So again, you want to find the area between A and B. Okay, so this is the area we want to find this time. So that's the area you want to find, right? So again, the area here is between, and this is, sorry, I'll write this down. This is y is equal to f of x. That's the curve, right? So the area again is f of x dx, which is the exact same as above, right? So, but there's one thing to find out here. This will return a negative value. So do you remember a while ago I was using the straight lines when I was doing my limits? That's the reason, because you know area is positive. So you just, if you end up with a minus 14 here, you know that the area is 14 because you can't have a negative area, right? So just be careful of that. So in other words, whatever value you get here will be minus. Just give it to the minus sign, and that's your area, okay? A tricky one. This is the tricky one, right? If you had something like this, if you do the y-axis and you do the x-axis like this, and when I say tricky, if you do it once, you remember it. And if you had a curve that was like this, okay, and you wanted to find it between A and B, okay, that's B. So this is the area you're looking to get. Now, what you do in this case, if you just put in A is equal to integral between B and A, f of x dx, like we did before, what you'd actually end up with is a positive area above the axis and a negative area below the axis, and they'll cancel each other out. Or you, like if they're the same, they'll cancel each other, and you'll end up with 0. But then you won't end up with the right answer, right? So what you do in this case is you must find out. We'll do examples in a minute. We must find out where the curve crosses the x-axis. Where does the curve cross the x-axis when y equals 0? So you substitute y equals 0 into your f of x, right? And you'll find out that coordinate, and we'll call this coordinate C, right? So you find out that it's C, okay? So your area in this case is equal to the integral between C and A, f of x dx, plus the integral between B and C, f of x dx, right? That's important there, okay? Just so in this case, and it'll come up again or later again, we'll do examples to become clear. So in this case, when it crosses the axis, right, if it's the x-axis or the y-axis, you must find out the intercept point, because if you just did it straightforward between A and B, you wouldn't get the right answer. They'd cancel. You'd like say in other words, if this area under here was 14 and this area was 8, then you'd end up with 6. That's not actually the right answer. The answer is 22, right? So the best way to do it is find out where it crosses the x-axis and then form new limits between C and A and B and C, like we've just done there. So the limits are the BC and CA, okay? So that's 3 of them. I'll just give you a second to draw that down. They threw this up one year, the next one, right? And I'd say it caught a lot of people, okay? So this is the fourth example. Is what if you have a situation like this? You have your y-axis, your x-axis. And what if the curve is going this way and they ask you to get the area bounded by the y-axis? Usually it's the axis, so this is A. And let's say this is B, okay? So this is the area we're looking for this time. Well, in that case, say if you had y equals, say, 7x squared plus 3x plus 2, right? You just flip it and you get x in terms of y as opposed to y in terms of x, right? So in this case, you say that the area, your limits are the same. It's between B and A, right? Of f of y dy. Okay, so instead of x, we just substitute x for y. Again, an example would make that easier. So in this case, usually like we have y is equal to the f of x, right? So for example, 3x plus 2, right? Okay, y equals 2. But what we want in this case is we want x, all right? We want x in terms of y, so we want x equals f, a function of y. So in this case, it would be like, let's bring it across, it becomes 3x equals y. Sorry, that's minus y, isn't it? No, I'm confusing myself now. 3x, I'll write out properly. 3x plus 2 is y is equal to that, right? So let's get the x out to one side, so it becomes minus 3x equals minus y plus 2. So divide across by minus 3. So that becomes x is equal to y over 3, isn't it? Y over 3 plus 2 over 3. Minus 2 over 3. Okay, that's what you do in an example. That's just an example. So I just rub all that out again because it's not important. It's just to show you. Okay. dx, sorry, dy, f of y dy. Okay, and the final one then, right? This is the one that comes up in the exam nearly all the time, right? So if you have a function like this, x-axis, and then your x-axis, and your y-axis, I'm going to change the color for this. So if you had a curve that goes maybe like this, you have another curve, a different color, goes like this. Okay, 2 different curves, right? And in this case, it'll ask you these are bounded by the 2 curves, right? So you want to find this area. So that's the area you want in this case, okay? So what you do in this case is you must find out the intersection of the 2 curves, right? So if you have a curve 3x plus 2, or 3x squared plus 2, and 7x plus 7, you let them equal each other, and you come up with a quadratic equation, and you come up with 2 results. And those results will be the points of intersection. So in this case, that'll be A, and that'll be B, okay? So let's call this y is equal to f2 of x, right? Just to differentiate, right? And this is y is equal to f1 of x. I could actually it might be easier, right? I'll do it a different way. I call this v of x, and I call this u of x, right? Because that's what we were doing earlier. So you have two different curves, right? So in this case, if you think about it, I do it in this kind of funny thing again. Hopefully it works. So in this case, if we found the area underneath the red one, right? So this area, I'll take this off again. We found that area and we subtracted it, right? I'm going to undo that. So that's the area, right, of v under the v of x curve, right? So, and we subtracted it from the area under this curve. Then we'd get the area in black, wouldn't we? Okay, that's clear. So that's why I'll write that out in mathematical terms, right? So we're looking at the v of x. So in this case, your area, which is this area here, right? So that's the area there for that one. So the area in this case is equal to the area under the curve Vx, so between B and A, V of x dx, minus the area between B and A of u of x, u x dx. Okay, that makes sense? I hope so. Be nice to have you in the classroom, like you can tell me yes or no, but I think that's it. So the best way to look, we do a few examples in past papers. So in example E is probably the most interesting. It's probably the one that's going to come up in the exam because it kind of incorporates all the others, right? So the trick here is usually you must first find the points of intersection, and these provide your limits. So again, remember, it's all about summation and limits. Well, the limits in this case are the points of intersection, okay? So it's all about building up the exam. So that E there, right, is really, really important. It comes up quite a lot in the exams. Now, I finished the background to all integration, right? So the fourth one and final one is, it wasn't there when I was doing integration back in the day, right? So it's just the average, and that's it. I think it's in the tables again, right? So you don't even need to learn it. Or you might, so maybe it's easy to learn it anyway. So the average value of a function over an interval. Okay, so what does that mean? Like, you know, the way you have a curve like that, right? You can all see me. So if you curve and you're between two limits, you want to find the average value or the average height. That's what this formula does, okay? So I'll write down the formula first of all, and we might do an example. So the formula is given by this, which is 1 over b minus a. These are the limits between the integral of b and a, and then the function f of x dx, okay? This is basically a formula for the average height between two limits between b and a over a given of a function over a given interval. That's what it's saying, right? So let's do an example, okay? Say you're given f of x, right? Fx, as you know, is y, right? So equals x squared plus 1, right? And we want to find, so it says find f bar, which is the average value of the function between the following intervals, between 0 and 3, okay? That's the question. But a lot of these things, I like to draw them out. Okay, so I'll draw this out here. I'm going to try and draw them. So that's your way of doing it again. Y-axis, x-axis. The function looks something like this. It's quite steep, so it's like that, okay? So that's f of x, or in this case is x squared plus 1. So in other words, y equals x squared plus 1. That's all it's saying, right? So you want to find it between 0 and 3. Okay, so I'll try and draw this out. This may not be so accurate. 1, 2, 3, 1, 2, 3, right? So when x equals 0, y is equal to 1. So I drew that wrong already. Forget about that, but that's just an example, right? So all you have to do in the exam anyway, you don't really have to draw the graph, right? So f bar is equal to 1 over, what's your b in this case? Well, it's 3. minus 0, then integral between 3 and 0, there are your limits, right, of x squared plus 1, because that's your f of x dx, right? So we work that out. That's equal to a third times, we integrate it. So x squared becomes x to the power of 3 over 3, and 1 becomes x between the limits of 3 and 0. So working that out, we get equals 1/3, filling in for 3, first of all, is 3 cubed over 3 plus 3, right? And then minus, is it minus or plus? Minus, and then that's filling for 0, so 0 cubed over 3 plus 0. That's right, isn't it? So check that, all right, equals, so 3 to the power of 3 is 27 over 3 plus 3, which is 9 over 3, times a third. So that's equal to 1 over 3 times 27 plus 9 is 36 over 3, which is equal to 36 over 9, which is equal to 4. So the average value is 4. So what that actually means is like between 3 and 0, the average height of that function is 4. Okay, that's all that means. That's the whole course done now. So we've about an hour left, so I think if there's not any questions at this stage, I'll move on, right? And we do some past papers. So that's 2021, I think. Yeah, it's quite an easy one. Okay. I have a few here. So I'll start with 2017. I think I have the graph of that. Okay, you can see that. I'm just making it bigger. Okay. Okay, so let's read out together. It says the graph of the function g of x equals e to the power of x. X is an element of R, and x is between 0 and 1, right? Is shown on the diagram below. On the same diagram, draw the graph h of x equals e to the minus x, right? In the domain 0, x is 1, right? So usually what I do in cases like this, right? If you want to, drawing that out is probably the easy way to do is write down a few x coordinates and then get the corresponding y coordinate and plot it, okay? So we know that x, let's say, and we can use what they have there, right? So they have 0, 0.2. Let's put it in 0, 0.2, 0.4, 0.6, 0.8, and 1.0, okay? So I'm going to do that. Okay. That's all they're asking us to do is actually just graph it, right? So e to the minus x. You can use your calculator. Okay, that's what I did. So we want to find y, which is equal to e to the minus x, isn't it? E to the minus x. That's what they're saying, isn't it? H of x. They're calling h of x. We call it y of x. So it's like h of x, right? So in other words, we're getting the x coordinate. We want to find the corresponding y coordinate. Okay, so let's do it in your calculator. I'll do 1, 0, e to the power of 0 equals 1, isn't it? E to the power of minus 0, because minus 0 or 0, right? Whatever is 1. Okay, so 0.2, if you put in 0.2 minus e to the power of x, sorry, e to the power of x 0.2 minus, you get 0.81. And similarly, going down, putting in 0.4 minus e to the power of x, or e to the power of minus 0.4, you get 0.67, you get 0.55, 0.45, and 0.36. So this is quite simple, like, it's just setting up your table like that. So then we just have to plot it, okay? So I'll make it properly, I suppose. So 0 is 1, So we know that's 1 point on our h to the x, right? The second one is 0.2. So 0.2 is 0.81. So we go up here to 0.81, which is roughly about here. 0.4 becomes 0.67. So that's 2, 4, 6, 7 is 0.67 is about there. 0.6 corresponds to 0.55. So that's 1, 2, 3, 4, 5, 0.55. Then would be, am I right? 5.5 there roughly. 0.8 is equal to 0.45. 1, 2, 3, 1, 2, 3, 4, 5. And 1 becomes 0.36. 1, 2, 3.6. That's pretty much the graph there, right? So I'll draw it, see what it looks like. This isn't going to be that accurate. So it's looking something like that. So I would just, for completeness, write down that's h of x equals e to the power of minus x. That's the first part of the question done, okay? Easy points, I would say. Now it says the second part of the question, I'll do it on this page. Yeah, I'll do it here. So that's part A. So part B says, find the area enclosed by gx equals e to the x, right? H, which is h of x, which is e to the minus x, and the line x equals 0.75, 0.75, right? Sorry. So we'll draw that up on the actual graph paper, right? So we see what we're looking for. So I'll do it in red. So 0.75 is here, isn't it? So we can just do that, right? Actually, I'll do it in a straight line. 0.7, 0.75 is about here. Okay. So what we're looking for here is this area. Okay. So again, the most important thing in integration is just setting up your answer, okay? So we know that the area that we're looking for, we call it A. So we say that the A is equal to the integral of g of x between 0.75 and 0. So we write down 0.75. 0 of g of x dx minus the area between 0.75, because that's our limits, right? And 0 and h of x. Okay, so now we set up our that's the answer, right? Now we just have to fill in our values for it, okay? So in this case, g of x is equal to 0.750 e to the x e to the x dx minus 0.750 e to the minus x dx, right? So we integrate e to the power of x, go to your log tables, you find out that that equals e to the x, right? Between 0.75 and 0. So we've already integrated now here, okay? And then it's minus, and e to the minus x becomes, we'll do it in brackets to make it easier, minus e minus 1 times e to the minus x, okay? Between 0.75 and 0. So working all that out, you'll get, so we can, the minus and minus cancel out, so it's e to the x plus e to the minus x, okay? So let's look at this first of all. So that becomes e to the 0.75 minus e to the power of 0. That's okay, isn't it? Yeah, that in brackets. So the minus there, the minus 1 becomes plus. So that becomes then e to the minus 0.75, right? Because it's minus x. And then that becomes minus e to the power of minus 0, which is just 0, okay? So obviously they'll cancel, won't they? Oh, no, let's leave it. Well, they will cancel. So e to the power 0.75 comes up. It says your answer to the nearest 4 decimal places, right? So let's think 4 decimal places. I think I did it to 3, right? It doesn't matter. So it's 2.117. Let's find out what it is. So 0.75, sorry, e to the power of 0.75 equals 2.1170. Actually, so it is 0, 2.1170 minus 1, because e to the power of 0 is 1, plus e to the power of minus 0.75. Just be careful of that point. So shift here, shift e to the power of x 0.75 minus equals 0.4723. I think, yeah, or 4. Okay, that's 4. Okay, minus 1. So working all that out, you get 1.1. I'll do it up to 1.1170. 0.4 minus 1 if it was minus 0.527. I'll do it minus 1 minus 0.5276. Okay, and then plus 1.17. And your answer is equal to 0.5894 units. Okay, so the last bit was fiddly with all the number crunching, right? But the most important part of this whole question was setting up this bit here, so in the square, right? That was the most important. Once you adapt them, the rest was just filling in numbers, okay? So that's 25 marks for that. Like that's, you know, that's not I wouldn't think that's difficult, okay? Once you understand the integration. I'll just give you a second to write that down. Okay, we're going to 2019. I think I have the yes, this one. Okay, so that says there, right? Part A is find the integral of 4x cubed minus 6x plus 10. Remember I told you before some of the parts were just really simple, right? So it says find the integral of 4x cubed minus 6x plus 10 dx. Okay, that's equal to, and you call it I, right? Doesn't matter what you can call it, f of x, call it whatever you want, call it I. So x cubed goes to plus 1 is x to the power of 4 divided by 4, and there's a 4 there already, so 4x cubed becomes x to the power of 4. And again, remembering the reverse process, if you differentiate x to the power of 4, you get 4x cubed, right? So it's just a reverse process. So minus 6x becomes 3x squared. Again, because x to the power 1, x n plus 1, so that becomes squared, divided by 2, and then 2. 6 divided by 2 is 3, so we get 3x squared, right? Plus 10x. Okay, and there was what, probably 5 marks for that. If you wrote down that, you would have got 4 marks because it's not complete. You must put in C. If there's one thing you learned from today, it's about putting in the plus C for the indefinite integral. Indefinite integral means there's no limits here, right? There's no limits there. See, we have no limits. So that's indefinite. Put in plus C. That was quite easy. Part B then is using the graph, right? So it says part of the graph of a cubic function f of x is shown below. Graph not to scale. The graph cuts the x-axis at 3 points A, 2, 0, B, and C, okay? So the first part of the question says, given that f prime of x equals 6x squared minus 54x plus 109, so it's giving us the derivative of the function, right? Show that f of x is equals 2x cubed minus 27x squared plus 109x minus 126. So the first thing we can say here is that f of x, because it says the derivative, right? Remember, the integral of the derivative is the original function. So we can say that f prime of x dx. I think that's one of the first things I wrote today, right? That f of x is the integral of the derivative, okay? So in this case, the integral of the derivative, but it tells us what it is, right? So it tells us that f of x is equal to 2x cubed minus 27x squared plus 109x plus c. Now the c is the issue, right? We have enough information to get rid of that c, because this is kind of a general, right? This is a general form. So if you didn't put in plus c there, that's this. The whole crux of this question was putting in the plus c, okay? No, if I wrote in the right one, let me just check. So f of x is equal to 6x squared. Okay, given that f prime of x, I'm just going to read out my own notes here, right, before I move on. Fx equals x, 2 zeros on the curve, so 0, 0, 2 times 8. I'm going to skip this question for now, right, because I don't want to waste your time. I think I made an error in my solution, but I'm just going to double check. Fx is f prime of x. Yeah, fx equals. No, I didn't. I didn't make an answer, right? So what I actually did there is I differentiated. No, it's overall okay. So I had that. I actually integrated f prime of x. So I skipped a line here in my notes. So I'll write it out again. So I'll undo what I just did there, okay? Okay, so we know that. So I'm actually going to, what I did here is I skipped a line, I did it in my head, right? So f prime of x, so we're just going to integrate this. Integrate 6x squared minus 54x plus 109, okay? We're going to integrate that. So when we integrate that, we get 2x cubed minus 27x squared plus 109x plus c, okay? And in our case, we know that c is equal to 126, okay? So therefore, f of x is equal to 2x cubed minus 27x squared. Sorry, I'm making a lot of mistakes here. My apologies. Hold on now. Let's go back. No, I stopped there. F prime of x. I integrated f prime of x, what we had, okay? And I got 2x cubed minus 27x plus 109x plus c. We were given that. We needed to show the second part, right? So we know that 0 to the point 20 is on that curve, right? So I can say the following. So I write down that the point 20 is on the curve. That's what we know. To get rid of the c, we must use the information that we had. The information that we were given is that the point 20 is on the curve, right? So now we have f of x. So f of x is what's drawn on the page there, right? So we have f of x, but we have the c that we don't want. And we're asked to prove that f of x is equal to here, this bit. We're asked to prove that. But at the moment, we're nearly there. It's 2x cubed minus 27x plus 109x plus c. So what we do is just plug in for 0 and 2, right? So f of x, that's the y, right? So that's equal to y. F of x equals y. So the y in this case is 0 and the x is 2. So we fill in for y is equal to 0, right? And then fill in for 2 right across here. So it's 2 cubed minus 27 times 2 plus 109 times 2 plus c. So we're just left with one unknown, okay? So that 0 is equal to 2 times 2 to 8. 2 cubed is 8, that's 16. 27 times 2 is 54. Plus 109 multiplied by 209 multiplied by 2 equals 218. So 218 minus 54 plus 16 equals 126, is it? I must have done something wrong there now again. So 2 times 27 times x squared. That should be x squared there. So that's power of 2, yeah. So that becomes 27 multiplied by 4. And that's 108. So that's okay. So 16 minus 108 plus 218 equals, thanks be to God, c is equal to 126. Okay, so then I fill that back in and we get that f of x equals 2x cubed. So I'm just filling that c back in up here, okay? 2x cubed minus 27x squared plus 109 times x plus, plus 126. Okay, so we've proved that. Apologies for the confusion at the start there. It's just my notes were, I was jumping ahead of myself. But so again, just to go over that question to be clear. So we were given f prime of x, and we were asked to show that f of x equals that based on the information that we got. So what we did is we had the f prime of x, we integrated it. So we had the f prime of x here, and we integrated that, and we got this, but we had an unknown c. And to get rid of that unknown or find out what that unknown was, we have to use the information that was given, and the information that was given was the 2, 0. So once you fill that in then, so in other words, it was y equals 0, or f of x, y equals f of x equals 0. And then I filled in for 0 there for that y, and I filled in 2 for the x's, and that left us with one unknown, that was the c is 126, and then I just plugged that 126 back into the integral. That's it. Okay. Part C of that question then. I can add some more pages here. Okay. So part 2 of that question was find the coordinates of points B and C. So find coordinates of B and C. Yeah, I'll just go back there, right, to the previous page. So what they're asking here is just to find the coordinates B and C there, right? So B and C, you can see that, okay? That's all they're asking. Now, what do we have? So we know 2 is a root, don't we? You remember, did you do this in there? I presume you did, right? So we know 2 is a root because it cuts the x-axis at 2, right? Is a root. So then we can say that x minus 2 is a factor. Okay, you've done this in another section of maths, I'm sure. Because when x, all we got that is when x equals 2, y equals 0, right? So we can say that x minus 2 equals 0. All right. So then what we do, this is something I haven't done in ages, but I remember it. You have to divide that factor into the equation, right? Which in this case is 2, so f of x, which is 2x cubed minus 27x squared plus 109x minus 126. Did I make a mistake? The minuses and plus there already up. Yeah, I did. So here, that should be minus 126. And that should be minus. Okay. So we divide that into that. So we must get this term must be the same as this. So we multiply it by 2x squared. That becomes 2x cubed minus, and you multiply 2x squared by the minus 2. That becomes minus 4x squared. Subtract that from that. We get minus 23x squared, bring down 109x minus 126. So we want to get that x up to the minus 23. So to do that, we must multiply by minus 23x. So it becomes minus 23x squared, multiplied by 2, becomes minus plus 46x. And the last becomes, what is it, 46x? Yep, so we do that. Subtract that, and you get 63x minus 126, and multiply that, so this becomes 63. Is it plus 63? And then 63x here, and luckily it becomes minus 126. That's 0. So now we know that. I'll just take this over here, and that becomes 2x squared minus 23x plus 63. Now to solve that, to get the other two roots, we use the quadratic formula equation as x equals minus b plus or minus the square root of b squared means 4ac all over 2a. So we can work all that out. Look, I'll do it quickly for you. This is 23 plus or minus the square root of 23 squared minus 4 times 2 times 63 all over 2 times 2 is equals to 23 plus or minus the square root of 529 minus 504 all over 4. So that's equal to 23 plus or minus 5 all over 4. So that's equal to 28 over 4 and 18/4. Okay, so that's they're your x coordinates, and obviously you know the y coordinates is y. So your b is equal to, what's that, 28 divided by, or sorry, 18 divided by 4, which is 4.5 times 0. And your c coordinate is equal to 28 divided by 4 is 7. Okay, that's your answer. I need that up there for a while because there's a lot in it. So again, like there's not much integration in that, right? But it was knowing that, you know, you were given one root, and if you divided that root into the cubic equation, you'd be left with a quadratic equation, and you'd use that quadratic equation by solving it to get the other two roots. Okay, so I would think that was a tricky question because, like, okay, whilst the part one and part one of B was quite simple, the part two of it was really difficult. Like if you didn't know how to, you know, where it crosses the axis is a root, which you've done in another section. I think that's even, is that a junior cert maths? It might be, but if you may have forgotten it. I did. I had to have a good think about it. But once you do it, like it's very little integration, that question really, but it's, so that's that one. That's 2019. Okay, so we'll go on to 2018 is the next one. So I do someone at my door there. They're gone. Okay, 2018. So question 6. I think I have the graph for that as well. It's this one. Okay, so I think you can read that. It says parts of the graph of the function h of x equals x and kx equals x cubed, where x is an element of the real numbers, are shown in the diagram below. So it gives you hx, graphs hx and the graphs k of x, right? Hx equals x is just a straight line, obviously, so it's just y equals x. So wherever you have, sorry, 2 seconds there, I just have to open the door for someone. Sorry about that, to leave my young fella in. All right, so parts of the, so you're given h of x equals x, which is a straight line, and you're given k of x, which is x cubed. So y equals x. So if we're along that line where you have x equals 2, for example, y is equal to 2 as well. So it's a 45-degree line. Okay, and you have k of x equals x cubed. So the first question there, A, is the question is find the coordinates of the points of intersection of the graphs of the two functions. Okay, so we write them down. We have h of x, which is equal to x. We have k of x, which is equal to x cubed. Okay, so they're the two graphs, of two curves, we'd say. Now, if it says find the coordinates where they meet, right, where they intersect, so we know to do that, don't we? We just leave them equal to each other. So we let x equal x cubed. So we work that out. So you get across here, you get, or divide across by x, you get 1 equals x squared. So x is equal to the square root of 1, right? So x, but then that's you agree plus or minus. So x is equal to plus or minus 1. And you can see that then from the graph anyway, like, you know, that's one intersection point and that's another intersection point. I suppose we can see from the graph too that 0 is also another intersection point, right? It says find the coordinates of the points of intersection of the graphs of the two functions. So we can write down then, right? I suppose another answer to x equals x cubed is if you had 0. So if you had 0 equals 0 cubed, isn't it? So then we have our 3 coordinates, right? So the 3 coordinates are -1, -1. Obviously, if it's on the line x equals y, the x coordinate equals, we solve for the x coordinate, but obviously the y coordinate is the same. So that's 1. We know that 0, 0 is an answer. And we know that 1, 1. So they're the 3 coordinates, right? Where they intersect each other. So there's 1, 2, and 3. They're the 3 points of where they meet. Okay, that was quite straightforward, I think. So part B of that was find the total area enclosed between the graphs of the two functions. So we can see there just from looking at the graph that it's symmetric, right? So what we want to find here is, I'll do it in a different color. So that's there, that's what it's asking us for, right? Now we can see, we call this A1, right? We call this A2. What we're looking for is A is equal to A1 plus A2. Okay, let's change color. Okay, so that's what we're looking to find. So in this case, you could say, like, you know that it's symmetric, because you could say that, we write it down here, A is equal to A1 plus A2, but you could also say that that's equal to 2 times A1. So we'll calculate A1 and just multiply it by 2. There's no reason why you can't do that, because we're saying that A1 equals A2, okay? So let's look at A1. So I do it the way around, I do this. A1 and this A2. Because it's always easier to work in the positive coordinate, right? So we say that A1 is equal to the integral between 1 and 0 of x dx minus the integral between 1 and 0 of x cubed dx. Is that okay? I can't get any response now, but I'll show you what it is. I'll do it in 2 different colors. So the area here in red that we're looking for is actually this area in blue, right? Which is the area underneath the curve y equals x, or hx equals x, right? And I take it away from this area. I'll do it in blue again, right? This area. If I subtract the triangle from that, right, then I'll get the area that we're looking for, which is the red area. So again, look, we've done that earlier. It's the same principle. So we work that out now. So that's equal to integrate x becomes x squared over 2 between 1 and 0 minus integrating x cubed becomes x to the power of 4 all over 4 between 1 and 0. So that's equal to 1 over 2 minus 0 minus x to the power of 4 over 4, which is 1 over 4 minus 0 over 4, which is 0. That becomes a half minus a quarter, which is equal to a quarter. But we're saying that A is equal to 2 times that. So we're saying that's A1. So we're saying A is equal to 2 times A1. So it's equal to 2 times a quarter equals a half. So that's your answer. A is equal to half, or half units. You could similarly calculate A1, right? A bit complicated with your minuses and all that, right? But you'll get the same, and you'll get a quarter as well if you calculated the area of 2. But again, there's no reason why, by looking at that, you say it's symmetrical, and you can say that, you know, the area is equal to 2 times one of them, obviously, okay? So the second part of that there really is just plotting. It says on the diagram on the previous page, using symmetry or otherwise, draw the graph K inverse, right? So K inverse is just x, maybe I'll do it. Okay, so part 3 of the question is on the diagram on the previous page, using symmetry or otherwise, draw the graph of K inverse, right? Which is the inverse version. Okay, so K inverse is equal to x to the power of 1 over 3, isn't it? But obviously it was x cubed, that was x to 1 over 3, right? So the inverse. So again, look, you could just plot, look, the way I did this is that you got the x and you got the y. So put in a few values like 0, 1, a half, 0.2, 0.8, etc. Right? You could do it like that. Plug that in to your x over cubed, and you'll get 0, you'll get 1, you'll get 0.79 here, for example. You will get 0.58, etc., right? And then you plot it out in the graph. I'll bring that graph back in. You'll get, I'll just bring that graph back in. So we stop. What I did actually when I started plotting it, you'll see something happening, right? So let's go back to that. Change the color. So obviously 0, 0 is on the curve, right? So I found out 1 is on the curve, so that's on the curve. And obviously you could do with the minus values as well, right? You get that this is on the curve. So we know that the intersection points are the same. So by plugging in some of the values I had here, so at a half, it was 0.79. So that's 1 there. So at a half, it was 0.79. So that's roughly about here. So that's a point. And then I plugged in a quarter, I think, or 0.2, because these are in 0.2. When I put in 0.2, I got 0.58. So that's roughly about 0.58. So then I saw what was happening straight away, right? So I plotted the graph. You can see that that's, look, it's the opposite, right? And you put it on the other side, it goes the same way. Okay? And that's the answer, right? So again, by just plugging in the values, 1 or 2 values, I saw straight away what was happening. And they're saying, and they say in the question as well, like, you know, they kind of give you a clue. They say on the diagram on the previous page, using symmetry or otherwise, draw the graph of k minus 1. So you can see in a few of the questions in the past years, they're also testing your ability to plot graphs. Okay, so they're doing integration, they're doing calculating intersections, they're also, you know, doing integration of doing and as also plotting curves, which is actually listed in the curriculum as well. Okay, so I'm going to do another question here now. Question 5. Yeah, it's a long question, but it's actually very straightforward. Okay, so this is 2014, and it's the project maths, but it's the same curriculum, so it'll be fine. So part A of that question was, so A is find 5 cosine 3 of x dx. So remember some of the rules, so we bring the 5 out straight away. So that's equal to 5 times the cosine 3x dx. So that's equal to 5 times, remember the rules are 1/3, so it's 1 over a, remember, sine of 3x. Okay, that's the answer, isn't it? No, don't forget your plus c. Okay, so it's equal to, just tidy it up, it's 5 over 3 sine of 3x plus c. Okay, the second part, B, it says the slope of the tangent to a curve y equals f of x, the slope, right? At each point on x and y is 2x minus 2. So it's giving us the tangent, right? And if you remember back to differentiation, if you had a curve and you differentiate it, that would give you the tangent at any point, right? And it also gives us one other bit of information here, right? It says the curve cuts the x-axis at -2, 0. So looking at that question again, what's it saying? It's saying slope of the tangent to a curve y equals f of x at each point x and y is 2x minus 2. So it's given us some function y equals f of x. It's saying that the tangent at any point on the curve is 2x minus 2. But it's also giving us the second bit of information. It's saying that the curve cuts the x-axis at -2, 0. So it's saying, so the question is, find f of x, right? So we have to find f of x. Now, let's write down what we have. We know we want to find f of x. So in mathematical terms, we're given f prime of x, which is the dy dx, or the tangent at that point, is equal to 2x minus 2. We have f prime of x, we want to find f of x. We remember back that f of x is equal to the integral of f prime of x dx. So that's equal to f prime of x, let's fill it in, is equal to the integral of 2x minus 2 dx. Let's do it here. So let's integrate that, and we get that 2 times x squared all over 2 minus 2x plus c. Don't forget your plus c. So that's equal to, so f of x, we already have it, f of x is equal to x squared minus 2x plus c. We have that c that we don't really want, okay? So when you have a c like that, you must use the what other information you have. And in this case, they told us that now we say now at x equals -2, y equals 0. Right? Because we're told that the curve cuts the axis at -2, 0. So we know that the point -2, 0 is on the curve. So we plug that in then. So we say that fill in for -2 for x. So you get -2 squared -2 times -2, what's yours? Right? Plus c equals 0. So working that out, we get that c is equal to -8. Then we can say that f of x is equal to x squared minus 2x minus 8. Okay, that's your answer. So again, like this question comes up in all different formats. Sometimes they just show it graphically, like in one of the earlier questions, they showed us that the curve cutting and they gave us the coordinate. But they did the same here, just did it in word format. Okay, I'll just give you a second to write that down. Actually, I'll do it up here altogether. So part 2 of that question, part B, right? Oh, sorry, don't know what happened there. Right. Remember? So it says find the average value of the interval between 0 and x over 3. So it says find f bar, right, over interval 0, 3. Okay. So we know our formula, f bar is equal to 1 over b minus a, between the integral of b, a, f of x dx, right? So we have our b, we have our a, and we have our f of x. So we fill all that in. So we say that, f bar is equal to, so it's equal to 3 minus 0 is 3, so that's 1 over 3 times the integral between 3 and 0, and f of x we know is x squared from the previous question, minus 2x minus 8 dx, right? Working that out, you get it equals 1/3 times the integral. X squared becomes x cubed over 3 minus 2 times x squared 1 over 2 minus 8x, right, between 3 and 0. Running out of space quickly here, equals 1/3 into 27 over 3 minus 9 minus 24, and then minus, obviously all those x's go to 0, right? So it's 0. All right, and then working all that out, you get that f bar is equal to 8. So again, like just having the formula there, the f bar is 1 over b minus a, integral between b and a of fx dx is all you needed to know there, just fill in your values. Okay. So the final part of that question, I think I might have the graph. Draw, no, it says right. It's again, I'll write it out. It says, it's plotting a graph, right? It says, draw the graphs of y equals 4x and y equals x cubed. Okay, in the domain -2 greater than or equal to x 2. Okay, so draw that graph between -2 and 2. That's all it's saying, and then usually x is an element of real numbers. Okay, so we can draw the graph. So first of all, I suppose is draw it. So y equals 4 of x. Obviously, let's say 1, 2, 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. We say so. Y equals 1. Sorry, when x equals 1, plus equals to 4, y does equal to 8. So that's the straight line. Obviously, y equals 4 of x. So we draw that with a red line. So it's something that goes through the x-axis or through the 0, right? So that's y equals 4 of x, and y equals x cubed. Again, we do the same thing again. We know that 0, 0 is on it. I do it in a different color, blue. So when y and y equals 1, or sorry, when x equals 1, y equals 1. So we know that that's on the on the curve, right? And when y equals 2, sorry, when x equals 2, we know that 8, so that's on the curve. So this is quite difficult to draw now, but something like that, okay? So this curve will go something like this. Apologies for this, let me go through this one. Okay, that's pretty much it, right? And it says between -2 and +2, right? So that's 2 there, that's 2, and that's 8. And that's 8, okay? And then 0, 0 is on it as well. Now, we want to find the intersection points. You can see what they are, right? Because we kind of we drew it well, okay? But let's find the intersection points, right? That again might help us with that. So if we just say y equals 4 of x, right? And y equals x cubed. So we just fill in that for that, right? We just say that obviously y equals 4x, so we put that in here, 4x equals x cubed. So that equals, get rid of the x's, you're left with x squared equals 4, so x equals plus or minus 2. Okay, so there the intersection points are. Obviously, when it's +2, y equals, so when x equals 2, y equals 2, 8, and if it's -2, it's -2, -8. Which is what we've drawn there. Look, that's pretty much there, -2, 8. Okay, and that's 2, 8, that's -8. So there are the intersection points. That'll help us on the next part of the question, right? So I'll do it here, try to keep it on the same page. Okay, so part 2 of that question is find the area of the region in the first quadrant enclosed by the 2 graphs. So in the first quadrant enclosed by the 2 graphs, so that's this area. Okay, so we know from previous, I'll do it in this funny color again, right? So we know that that's this area here of the triangle, minus, I'll do it in a different color, pink, minus this area. Okay, so one is under the curve, the y equals x cubed, one is under the curve y equals 4 of x. So let's set that up mathematically. Go back to this. So we know that that's between 2 and 0. So we know it's between here, 2 and 0 is there. So we say that's 2, 0. So the red curve there, right, that's the 4x dx. 4x dx minus same limits, 2 and 0 of x cubed dx. Okay, so let's integrate that. Then you have 4x squared all over 2 between 2 and 0 minus x to the power of 4 all over 4 between 2 and 0. So that's 2. So 4 divided by 2 becomes 2 there, right? So it's 2 into x squared, which is 2 squared minus 0 squared, and then minus a quarter times 2 to the power of 4 minus 0. So that's 2 into 4, isn't it? Yeah. Minus a quarter times 16. So that's equal to 8 minus 4. So it's equal to 4. Okay. So the area is 4. That's 4 units. All right. And then it asks, write down the total area enclosed between the 2 graphs and gives you a reason for your answer, right? Obviously, that's symmetrical, right? So they're equal. So part 3 of that question, you could say area is equal to 8, right? And due to symmetry. Okay, it's nearly time up there, right? I'm going to stop at that point because we did quite a lot there now this morning, quite a lot to digest. But as I say, right, you saw the kind of flavor of the questions over the last few years. There's not a whole lot they can ask you. Like, let's go through the curriculum again. 1, recognize integration as a reverse process of differentiation. We've done that. Like, they use it quite a lot when they say f prime of x, then you know that if you reverse it, you're integrating it. So when you were given the tangent and you want to get the function, you know how to do that. Using integration to find the average value of a function. Well, that's just plugging in that formula, right? Very easy. And then there's only 4 things they can ask you, right? Integrate the sums, the differences, multiples of x to the power of a to the power of x, sine ax, cosine ax, right? And the last one then is determining the areas of plane regions bounded by polynomial and exponential curves. So at this point, Eamon, I'll just throw it back to you there, and maybe if there's any questions, the last, let's say, 5 minutes that anyone has, we can answer them.
That's great, Mark. Thank you for a great presentation. I wonder if any of the students have got any questions for Mark. It was a great time.
As I say, I think it's something, the last few years, it's been the whole integration has been kind of tagged on. Like there's been one full differentiation equation or question, and then the second question might start off with differentiation, and the second and third parts of the question are integration. So like obviously they're intrinsically linked. So that's the way they've been going the last 2 years. But there's not, I know if you've never done integration before, that's a lot this morning, right? But really, if you go back to the very first thing, the chapter 0 I did, and if you can really understand that like integration is all about summation, getting something that getting the area of something that like in this case, it was a thin strip, which was effectively a rectangle, and you sum up all of those between the upper limit and the lower limit. That's really all integration is doing. And also obviously recognize that it's the reverse of differentiation. But I think if you do differentiation, you'll see that. And then the other one is just, the average value. That's just a formula you need to learn. That's quite, so there's not a lot they can ask. But one thing that you can see, which is common throughout all the questions, is being able to plot a curve. It's being able to see what y is, what x is. And if you get stuck in an exam and you can't see it, just fill in loads of values and see, and you'll get the curve, after a while you'll see what's happening. So they're the tips I give you.
So if there's no further questions, I'd just like to say thank you to Mark. The recordings will be available on YouTube on the CEIA Cork channel, and we'll hopefully see you next week for the differentiation tutorial with John Forrest. Okay, so bye for now.
Bye.
See you then.